Okay, now I'm going to dive into trying to teach you what the first objective is, and that is to find the inverse of a functional relation. So, finding inverses. Recall the relation is a set of ordered pairs. So, a relation is just any set of ordered pairs that we create. The inverse relation is a set of ordered pairs that is obtained by exchanging the coordinates of each ordered pair. The domain of the relation becomes the range of its inverse, and the range of the relation becomes the domain of its inverse. So, in other words, what they're saying in these words is, if we have a relation that is defined by a set of ordered pairs x, y, then the inverse becomes a set of ordered pairs y, comma, x. The domain of your original function becomes the range of your new function, and the range of your original function becomes the domain of your inverse function. So what we're seeing here is that these actually change roles. The x and the y's change roles, but the range becomes a new domain, and the domain becomes a new range. And that's the terminology that they're using. They have a pretty good description here that if they're inverses, it's using just the same concept, but if you have A and B, if A and B are ordered pairs of a relation, then the inverse contains the flip of that ordered pair. And here's some more examples of the same thing that we've illustrated several times. So, all right, in our first example here, this geometry, it says the ordered pairs of the relation are the coordinates of the vertices of a right triangle. Find the inverse of this relation and describe the graph of its inverse. So if you watch the intro to this lesson, it should be fairly easy because the ordered pair -8, -3 will become the ordered pair -3, -8 for the inverse. The original ordered pair -8, -6 will become the ordered pair -6, -8. We're switching the roles of our inputs and outputs, or the x's and the y's. Other terminology is domain and range. So the ordered pair -3, -6 becomes -6, -3. So these are the ordered pairs of our inverse function, or inverse relation. Now they said describe the graph. Well, if you watch the introduction, then we know that the inverse of these two graphs should be a reflection. Sorry, let me try that again. Reflection across the line y equals x. So I'm going to try using Desmos to show you the reflection of this graph to give you more visual evidence of this relationship. That's important that we remember. So Desmos said, I'm going to graph the three ordered pairs of our first triangle, and I'm going to do my best to connect those so that they form a triangle. Okay, I can get a marker to work on this. Okay, so that's going to stop that. So I can't actually draw the physical triangle. Technology will not allow me to do that. But I am going to graph the other ordered pairs that are the inverse. So the inverse of -8, 3 is 3, -8, and the inverse of the other, and the third point. And these points should be a reflection across the line y equals x. So what I should see is that this ordered pair of 8, -3, this point here, should be the reflection of this ordered pair right here. So those two are actual ordered pairs that get reflected across that line. And then the ordered pair -8, 6, that's that ordered pair, is the reflection of 6, -8, which is down here. So those are inverse pairs. And our final set of ordered pairs are the -3, -6 gets turned into a -6, -3, and we can see the reflections across the line y equals x of each of these ordered pairs. Apologize for not being able to make the triangle, but the markers would not write on that surface. So that's what we're asked to do in that first example. We're supposed to create the set of ordered pairs and then describe what the graph will look like. And if we do it correctly, they should be a reflection across the line y equals x.